So students, welcome back. In this session, we shall see the concepts of object-oriented programming, its important features. We have seen procedure-oriented programming in the last session. Procedure-oriented programming gives importance to the procedure or steps involved in the problem. Real world modeling. In the case of procedure oriented programming, it can give only poor real world modeling of things, and it is difficult to make new data types, as well as if we make any change in data variables and all, we have to modify the entire code where that data typings or newly added data is affected. So there are certain limitations. Here we are going to see the basic concepts of object-oriented programming. We have seen that in object-oriented programming, it is given more importance to data. There we can compartmentalize larger problem into small units, and these units can be separately solved and finally joined together to get the ultimate final solution of a larger problem. Also, we can make new data types. User can define his own new data types. So there are many advantages like that. So here, everything in object-oriented programming, everything is based on objects. Everything is based on objects. This is the basic building block of object-oriented programs. So what is an object? It is similar to that of objects that we see. See, table is an object. Table is an object. A bird is an object. A human is an object. A vehicle. All these are objects. Anything that we see which have some properties. Properties. Objects have properties, or can say they have states, and objects have we can say characteristics. Some characteristic. It defines. It gives these characteristics, distinguishes an object from another. Then an object have behavior. An object have behavior. So let us see what are the properties and behaviors. See, in the case of a car is an object. A car is an object. A car has its color, its cc, its capacity, its size. All these are the properties. By changing the color of a car, a color can be distinguished. cc may change. The capacity to occupy persons may change. Size may change. So these are the properties. Now there are some behaviors. Behaviors. What are the behavior? It can move. It can move. It can stop. Then it can raise horn. It can blow horn. All these are behaviors. Now let us take another example. Say a bird. Bird. A bird has also its color, its size. Then say length of wings, length of beak. All these are properties of birds. All these are, sorry, all these are properties. All these are properties. Now a bird can fly, a bird can make sound, a bird can walk. All these are behaviors. Similarly, in object-oriented programming, we have seen that in object-oriented programming, real-world modeling of objects is easy. So we can make objects similar to that of real world. So here in C++, an object is actually an instance of class. An object is, we say, it is an instance of class. So there arises a question, what is a class? An object is an instance of class. We have seen an object has properties and behaviors. Properties and behaviors. So actually, a class is a way to define object. A class is a way to create objects. Now, technically, in C++, a class is a class in C++. A class is user defined data type. A class is a user defined data type similar to that of a structure, some minute variations. A class is a user defined data type. A class combines data items and functions. A class combines data items and functions. Or we can say a class is a way to bind data items and functions together. We have seen in the case of structure, a structure is a way, a structure is a user-defined data type that combines logically related different types of data items. Here, class combines data items and functions. So apart from structure, a class contains a function. The first thing is, class is a user-defined data type. A class combines. What are the things that contain in a class? A class contains data items and functions. So these data items and functions are together combined with the help of a class. Now we can say class is a blueprint. Class is a blueprint for objects. A class is a blueprint for objects. Or we can say, instead of blueprint, we can say it's a prototype or template. A class is a blueprint for objects. A class is a prototype for objects. A class is a template for objects. It means we make objects of this type. We make objects of class. So an object is made from this class. Class defines how an object should look like. Now, a class is defined using keyword class. In the case of structure, a structure was defined using struct, keyword struct. Here, a class is defined using keyword class. Let us see an example class. So the name, a class is defined using the keyword class. Defined using the keyword class. Then suppose we are going to create a class named box. So we have given the name box. Now opening the curly braces. There are two things inside a class. Apart from structure, we have variables as well as functions inside a class. The variables inside a class are called data members, and the functions inside a class are called member functions. So here, for the time being, we are declaring some variables, say float length, float breadth, float height. So these are the properties of the object that we are going to create. For every box, there will be a length, there will be breadth and height. So this determines. We can add more properties. For the time being, we are taking only length, breadth and height. Now, usually, while declaring these variables, we use a keyword private, private, and a colon, not a semicolon, and a colon, private. See, this private is known as access level. Private is known as access level. There are three access levels used inside a class. They are public, private and protected. All these three are keywords: public, private and protected. These keywords determines the accessibility of the variables and functions inside a class. By default, if you are not using any access labels, all the elements, whether it be variables, data members or member functions, all become private. By default, the access level is private. Usually, we make data members private and member functions public. That is the convention that we followed in order to define a class. It can be changed. Sometimes we use protected, and there are some public variables, the chance for public variables. But we can say most of the time the data members are declared private and member functions declared public. Now we are going to create some functions, define some functions inside this. So we are using the keyword public. After this keyword private, all the variables that are coming after this private are private in nature, and here we are using the keyword public. After this public keyword, anything written are treated as public until another access label is present. So here we are going to create a function called volume. Float volume. We are writing return length into breadth into height. So this is the function to return volume. Now we are creating another function, void read data, and scene length, breadth, height. Now one more function, void show volume. Cout volume. And finally we are closing the curly braces and putting semicolon. So this makes definition of a class named box. These are called data members. These are data members. Here this one, this one, and this one. That is the volume, read data, and show data, show volume. These three are member functions. Member functions. Now this private is access label. This public is also access label. So here name of the class is box. It has three data members, namely length, breadth, and height. This class has three member functions, namely volume, read data, and show data. Now we can create instance of this class. Actually, this is the template. We say this is the template or blueprint or prototype of an object. A class, this box is prototype of something that we are going to create. So actually a class is a prototype for an object. As in the case of class structure definition does not allocate memory. Memory is allocated for a structure when a variable of that type is created. Here also, this will not make any memory allocation. When we create a variable of this class, then only memory is allocated. We never say variable of a class. Instead, we say instance of a class. Instance of a class is known as an object. We never say, as in the case of a structure, we say variable of a structure. But here, we will never say variable of a class. We will say object of a class. Object of a class. Now, how we will create an object of a class? How we can create an object? So here we have the class box. Now, how to create an object? It is very simple. We have a class named box. This is a newly created data type, user defined data type. Now we are going to create an object of this class, say B1. This will create an object. So B1 is an object. B1 is an instance of this class box. What happens? There is B1, memory will be allocated for B1. B1 has length, B1 has breadth, B1 has height. These are the three things. And also there are three functions. What are they? The three functions are volume. A function called volume is there. Read data is there. Show volume is there. These are the three functions. These functions are attached with this. This copy of functions are attached with this. Now suppose we are creating another object, box B2. What happens? Another copy of memory from memory is allocated. This also has breadth, length, breadth and height. But it will not create copy of the function. Instead, this function will be shared. Functions will be shared. So, this is the way of creating an object. An object is an instance of a class. An instance of a class is known as object. An instance of a class is known as an object. We will never say a variable of a class. Instead, we will say an object of a class. Now, how we can call the functions? How we can execute the function or invoke the functions inside a class? We can execute functions inside a class using the object. Suppose we want to read data to the object. We have created box B1. We can write a statement like this: B1 dot read data. With the help of dot operator, we will call the function. Then this function will be executed for B1. Then B1 dot volume. The volume will be calculated with the data inside B1. The volume will be calculated. The function will be executed for B1. So we can call or we can invoke a function in this way using dot operator. Now, what are the features? What are the qualities of object-oriented program? What are the merits that we get over procedure-oriented program? We can write the points like this. Features are: 1. Encapsulation. Second one, say we can write features of object-oriented program. Encapsulation. Abstraction. Modularity. Inheritance. Polymorphism. These are the important features of object-oriented programming. Encapsulation, abstraction, modularity, inheritance, and polymorphism. What is encapsulation? Capsuling things. Encapsulation. Making different things together into a single easily handleable unit. That is called encapsulation. Encapsulation is binding of data, that is data members, and functions, member functions. Together is called encapsulation. Binding of data, that is data members, and functions, member functions, together is called encapsulation. We will take a real-time example of a car. A car has different types of devices inside. It has a battery, it has electric motor, it has diesel or petrol engine, it has gear system, brake, there are different steering, then is a audio system. So all these are put together as a single unit, easily handled, easily in a way that can be easily in a handy way, is actually encapsulation. See, there is electrical unit, battery. When the user gives the key or the driver gives the key, the vehicle gets started. So the battery power is given to the electrical motor. That electrical motor gets started. That starts the diesel engine or petrol engine, and so on. So all these units are put together. That is called encapsulation. Now, the second one is, in object-oriented programming, there is abstraction. What is abstraction? Abstraction means hiding the complex things from the user and only providing the necessary, easily handy things to the user. Abstraction is hiding complex things from user and providing only necessary, easily accessible things to user. Hiding complex things from the user and providing only necessary, easily accessible things to the user. This is called the abstraction. The class internals, the private data, the data that are supposed to be kept secure are actually hidden from the ordinary user. So, only providing the essential things to the user and hiding the unnecessary things or complex things from the user. That is called abstraction. Now, the next thing is modularity. Modularity means the ability to compartmentalize larger problems to simple individual units that can be separately solved and solutions of subunits can be later integrated to get final ultimate solution. That is called modularity. We can divide larger complex program into different subunits and they can be separately solved independently and the solutions can be finally integrated together to get the solution for the larger problem. Ability to compartmentalize larger problems to simple individual units that can be separately solved and solutions of subunits can be later integrated to get final ultimate solution. Suppose we have a big problem, school administration. It can be divided into two parts, staff, students, subdivided into two. This can be further divided, staff, selection, payroll, job schedule, etc. Students, admission, exams, library, lab, etc. These selection process, this payroll process, job scheduling, admission, exam, library, lab, these can be separately solved and the solutions can be put together to get the school administration software. So this is called the modularity. So these are different modules. Selection is a module, payroll is another module, the job selection is job schedule is another module. So these problems can be separately, subunits of problems can be separately solved, and you will get the final solution. Then comes inheritance. Another feature of object-oriented programming is inheritance. Inheritance is the property through which a class acquires the properties of another class, or the ability to inherit the properties of one class to another is called inheritance. The property through which a class acquires the properties of another class, this is called inheritance. There are different types of inheritance, like simple inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. The types of inheritance are single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. These are the different types of inheritance. So here suppose we have a class that can be represented like this. Say class A, already existing class. We are going to create another class, say class B. We want to take some properties of class A to B, and we will give some additional properties to B. So here we want some properties of A here. So we inherit the properties of A to B. This is called inheritance. Here class A is called superclass. Superclass, or base class, or parent class. The class from which the properties are inherited to other class is called the superclass, base class, or parent class. And the class B is the class we are going to create newly and has the properties of A. We are inheriting the properties of A to B. So this is called subclass or derived class. Subclass or derived class of child class. So this process is called actually inheritance. We can write statement like this. Class. We are now going to create class B, and this is the inheritance operator. Then we are going to derive from A. This means class B inherits A. Then we can write statement like this. Here there will be codes of B, and properties of A will get already written class, already created classes, properties will be get inherited to class B. So this is the way of inheriting the properties. So here this is done in single step. So this is called single inheritance. Now suppose we are inheriting the properties of B to some say class C. So here this is done in different levels. So this is called the multi-level inheritance. The properties of A is inherited to B. The properties of B is further inherited to C. So here this is done in more than one level. So we call this as multi-level inheritance. Now suppose we are we have say class C here, and we are inheriting the properties of C to B. Class C, some properties of class C is inherited to B, some properties of class A is also inherited to B. So this B is created from multiple parents. So this type of inheritance is called multiple inheritance, where there are more than 2 or more base classes and one derived class. This is called multiple inheritance. Now suppose here we have class C. So class C and class B are created from A. This is called hierarchical inheritance. Class B is derived from A, class C is derived from A. This is called hierarchical inheritance. Now suppose we further proceed like this. One more, say class B. So here we have multi-level inheritance, we have multiple inheritance. Such an inheritance is called a hybrid inheritance. So these are the different types of inheritance. Now, the last feature is polymorphism. Polymorphism means ability to behave differently depending on situation or data provided. This is called polymorphism. Ability to behave differently or ability to process data differently depending upon situation. Situation means that depending upon the data provided, from where it is called, from which, based on which data it is called or the function is invoked, etc. So this is called polymorphism. So these are the features of object-oriented programming. Now we have two types of polymorphism. One is called compile time polymorphism. Compile time polymorphism. And second one, runtime polymorphism. Two types of polymorphism. We have compile time polymorphism and runtime polymorphism. Compile time polymorphism means, suppose we are making a function call and there are more definitions for a function, and depending upon the call, which function definition is to be executed is determined at the compilation time. It is called compile time polymorphism. See, we have function overloading, and operator overloading. These are examples for polymorphism: function overloading and operator overloading. Function overloading means multiple definition for a function. A function with same name but different signatures and different definition. Suppose there is a function called area. That function calculates area of a circle when radius only is provided, calculates area of a rectangle or square when length and breadth are provided, calculates surface area of a box when length, breadth and height are provided. So the function name is area, and that function behaves differently depending upon the data provided. If single data is provided, it calculates the area of a circle. If length and breadth are provided, it calculates the area of a rectangle, and so on. So multiple definition for a function. This is called function overloading. And operator overloading, multiple definition for operator, or the operator behaves differently depending upon the data provided. See, we know plus is an operator. If a is an integer and b is another integer, a plus b will be performed. Suppose a is 10 and b is 20, a plus b will give us 30. Where plus performs addition operation on numbers. Now suppose we have a class called matrix, and a is a matrix and b is another matrix. Suppose we want to write a plus b in our program. Here plus means, since a is a matrix, b is another matrix, here plus means addition of two matrices. Then what happens? Similar row column members elements are added together and it will create another matrix. So this plus performs matrix addition. And suppose C1 plus C2, suppose C1 is a complex number and C2 is another complex number, this plus performs complex number addition. So the definition of this plus changes. That is called operator overloading. These function overloading and operator overloading are compile time polymorphism, which means which function is to be executed or which calculation is to be done will be determined during compilation of the program. This compile time polymorphism is also known as early binding. Early binding. Now, runtime polymorphism. Runtime polymorphism, the binding is done. The calling section and the called section, its binding will be done during program execution. So it is called late binding. Late binding. See, inheritance as well as pointers operations are done during runtime. Now finally, a term called message passing. Message passing. See, the members inside a class, data elements or data members inside a class cannot be directly accessed by the outside agents. So for accessing members inside a class, we will call functions, member functions inside a class. So calling a member function inside a class is called message passing. From another class, from another section, we want to access the elements of a class or data members of a class. We call the function like this, say a dot get data. So this is called, this type of call is called message passing. So these are the basic features of object-oriented programming. We have data abstraction, encapsulation, modularity, polymorphism, and in inheritance. We have seen different types of polymorphism and different forms of inheritance. And we have seen how to inherit the properties of one class to another. We have seen different access labels like private, public, and protected. All these are keywords. So this only gives a brief introduction about the class. So that's all for the session. Thank you.